Good morning to all of you.
Good morning to our attendees. Good morning, Andrea.
Massimo. Good afternoon to all of you that are in the Asia Pacific area, and maybe good night to those are in American areas. Thank you for joining this Gemini webinar, and let's wait another few seconds that people are connecting. And today the topic is SIL3 products, SIL3 products, applications, and so we have a mix of technology and standards also. And let's wait a few seconds and then we can start. Just a few information, just for making questions, please use your Q&A button. Don't use chat box, please. It should be not allowed, but anyhow, use a Q&A, please. And we can start right now. Okay, so thank you. As you have seen, there is a SIL3 safety instrumentation explosive environments, and the speakers today are so myself, Andreas Program, Global Account Manager at GEM International, and working in the market since let's say more than 20 years. There is also Massimo Pagani, our product manager, and also responsible for customer support. Massimo has a very long experience in applications, so it can be of help, of course, if you have any special questions. Just information about the GMI, who is handling this webinar. We produce intrinsically safe and SIL certified devices for critical application for oil and gas, chemical, petrochemical, where TCS, ESD, and PLC are used. More than 40 experience, complete production in Europe, Italy, Milan, but we have also offices all over the world, in Asia Pacific, in Middle East, in Americas with 2 offices, and in Europe, of course. More than 200 people. We are really engaged in what is functional safety, EX, and also we provide trainings and webinars. As you can see, today is a webinar, it's a free webinar. About our production, we produce completely in our facility in Milan. As I would say, we have a complete traceability for incoming components, outgoing products. We have a full testing 100%. We also provide 5 years warranty and 10 years guarantee availability. Those are our standards. So we have different accreditation bodies, certification for all markets and applications. So for Europe, for Americas, for Asia, we have also certification for China, for Japan. We have for Russia, of course, and special marine certifications. The company is also certified as a functional safety management, SIL3, and that's very important because the product cannot have just a SIL certification for the electronics for the products, but also for the design. This is the range for the product we produce. So our modules are used in combination with PLCs, so can be intrinsically safe and non-intrinsically safe isolators or barriers, safety relays, safety power supplies, multiplexer, termination board for all PLC and DCS in the market, hard multiplexer, surge protectors, indicator, and also the last bullet is regarding the courses we provide. Some names. We provide services for system vendors, EPC, OEM, and the users where we are specified. We do have some polls. We want to also start with the first polls and yes, if you want to write your answer, how is SIL certification important for the Zardus area? And we have also special question that you made during your registration. We want to answer after the webinar. So there are very specific, are very connected between SIL and Hazard application, the importance, if it's mandatory or not, and so on. Okay, thank you for answering. Just wait a few seconds and we see that there is SIL certification very important for you for Hazard. Most of you are writing and answering this way. Okay. Let's wait another 1 second, 2, 3, 4 maximum, and that's okay. I'm gonna stop it. Thank you. We want to share also the result, and you can see that is very, very important that the SIL certification for most of you, and so we can continue. Okay, now is we can continue with the next slides, and is Massimo turn. Massimo, we can talk about the safety relays part.
Okay, thank you, Andrea, for your introduction, and welcome to everyone also from my side in this GMI webinar, where we dedicated the first part of this webinar to the smart relay and their application, because safety relay are a key part of a SIL loop. And after, we will then continue by involving instrumentation such as barriers and power supply and so on. Well, let's start by introducing the concept of SIS, Safety Instrumented System. SIS is a set of subsystems that make up the safety loop. Within this safety loop, we have field devices such as transmitters or sensors, which allow us to control, detect, and measure variables in the field, such as temperature, pressure, or other. They are driven by barriers or isolators that provide for limiting the current towards the hazardous area or to isolate field instruments. And in turn, the signals sent by the field loop will be acquired, managed, and interpreted by what is the brain of the SIS, our PLC or DCS safety system, which will decide on any action to be taken to make a plant safe. And again, power interfaces, as can be a safety relay, which will then act on a valve and on actuator, which allow us to bring the SIS in safety in case of need. The main concept that needs to be understood is that every single element of a SIS must be sized with a SIL level, such as to allow us to obtain the overall SIL of the SIS required. All components of a SIS, including power supplies, to which will be dedicated a part of this presentation, must be safety related and have a SIL level. This helps us to have a safety loop, and with the correct redundancy, a loop with high availability to the process. Well, let's start examining those that are a fundamental part of a SIS. Let's talk about the safety relay. The safety relay can stop or initiate a movement in a controlled, safe manner by opening, closing valves, start-stop motor, and so on. And they must conform and adhere to the ESC 61500 and the industrial standard. But not only in oil and gas or process industry, but in general, a safety relay can be used where a failure of the relay can cause serious accident to human, environment, and assets or an image. Well, but what are the typical cases where a safety relay is required? Well, typically we must use a safety relay in all those applications where the controller, the digital output card of our PLC, for example, is enabled to activate a field device due to its limited potential in relation to the voltage and current involved. or in those applications where multiple contacts for simultaneous activation of multiple loads is required. Or again, in those applications where the safety function that the controller must perform needs to be inverted. Furthermore, the safety relay in their most complete version, we are talking about the smart relay, allow us to extend the diagnostic capability of the safety system, introducing the predictive diagnostic discourse, especially useful in fire and gas application. But what is different from a standard to a safety relay? Andrea, I leave you to explain this point.
Thank you, Massimo. So we can say that standard relay is not a safety relay. It's a completely different, and they cannot be used in a SIL. So the importance of SIL relay is that there is a no warranty ability to perform a safety function. Okay. So what is safety function? Safety function is let's say the necessity to obtain a safety status in case of problem. So it can be open relief valve or activate the fire extinguisher system. So there are applications where like ESD, IPS, and BMS, where the safety function is normally energized and in. So, and in case of safety, you want to reach the de-energized status for safety. While fire and gas, you are the opposite. So you are normally energized, de-energized, sorry, and you want to energize in case of safety. So this is very, very important. And we can say that a safety relay is a mix, of course, of components, because inside the PCB there are multiple components, probably 100, even more components. And but the cell level for these products or another product, of course, is given by the FMED analysis. And the FMED analysis is the single or the addition of all the FMED values of the dangerous and the safe failures of each component. You see in the table there, where, of course, we can simulate what happens in case of failures for each component. So you can understand that the calculation is very complicated and they cannot be done afterwards. So the product has been designed to be a cell. So when we decide to use a product components inside the relays, inside the hardware we are doing, each component has to be, let's say, released by the manufacturer with real, let's say, FMEDA analysis of the single components. And in the end, we obtain the cell level for the products. Massimo, to your turn again.
Well, let's give now some example of real application in the process board, distinguishing between digital input relay and digital output relay. Well, digital input relay are those devices able to manage a voltage-free contact position in the field. And well, this digital input relay typically communicate the state of this contact to a digital input card of the safety system. A typical example is a proximity sensor NAMUR type, which is fed and acquired through a galvanic isolator for digital signal. In this case, the sensor in the field is a simple contact free of voltage, which needs to be read and interpreted by our devices, digital input relay in this case. But what happened in the field when we have a wet contact by a voltage, which can different values such as 48 volt DC, 230 volt DC, 24 volt DC, and so on. In this case, a digital input relay cannot be used because its input front end is not available to accept external voltage from the field. In this case, we will have to use a digital output relay that is a device that, depending on the voltage that arrives at its command, activates or deactivates an output content and communicates to a PLC DCS the presence or absence of a voltage in the field. The classic example could be the one where we need to communicate two PLC DCS systems placed in two different contexts. The digital output card of one of the two systems controls our digital output relay, while a digital input card receives the contact status of the digital output relay. But what may be the main problem that can be encountered using a relay for this purpose? First of all, we have to keep in mind that usually a relay is designed to switch important value of current, while usually towards a digital input system, the currents in play are very low, typically less than 100 milliamp. In this situation, we can face problem of oxidation of the relay contacts. Therefore, it's essential to choose a safety relay with golden plate contacts, which allow us to switch thanks to its high conductive performance, even current lower than 10 milliamp. To deal with this problem, GMI has equipped most of the safety relay of the new series with golden plate contact to make them available to this particular application. In addition, GMI has developed a universal device able to receive at its input different voltage level, selectable via deep switch, while the output provides a free voltage contact optocoupled type compatible with the all PLC DCS system, which ensure maximum conductivity even at lower currents. This device specifically designed to work in this kind of application where we have to communicate between two systems distant from each other, or where we have to signal to a system presence or absence of voltage. Well, now let's look at diagnostic safety relay, commonly called smart relay. This relay allows us to constantly monitor the load and the line in the field and report to our system if a fault is detected in the field. The diagnostic of this relay is active both in on-relay condition and in off-relay condition, allowing us to know the health of the loop, especially in fire and gas application. But why going for a smart relay? Nowadays, full diagnostic is typically required along the full loop. However, many widespread systems do not support diagnostic inside their digital output cards. Smart relay make diagnostic available to systems that do not support it. In other cases, many modern digital output systems have their own diagnostic capability, but in many applications, they cannot directly drive the load because they are voltage and current limited, typically no more than 500 milliamp at 24 volt DC. As loads such as valve, sound, beacon, and so on frequently require more than 24 volt DC and or 500 milliamp. In these cases, the relays are essential to make up for the shortcoming of a digital output in terms of power supply to the load. However, when using standard relay, the digital output diagnostic cut out on the relay coil and fail to reach the load in the field. As opposite to that, smart relay can go beyond the typical voltage current system limitation while keeping the full load diagnostic. Even if modern systems can perform load diagnostic, their capabilities may be limited. For instance, air leakage monitor may not be supported, or extreme load, for example, beacons may always be reported as an open circuit to the system. Smart Relay may offer a solution to extend the digital output diagnostic capability. Smart Relay also introduced the possibility of mirroring a fault in the field directly to the digital output card of a system compatible with this function. Let's see in more detail what is the mirroring function of a Smart Relay. This function allows us to reflect information related to the field fault directly to the supervised digital output card of a PLC. This is both in off state through the pulse test system and in on state by reading the static return of current. The digital output card of the PLC system can detect the information related to the field fault. The system, through an upward impedance variation of the relay input circuit, allows the supervised digital output card to see the fault in the field. This system allows considerable saving in engineering cost, as it allows us not to use a dedicated digital input card for this purpose. For this scope, GMI integrate its range of Smart Relay with two different models. The D5096S and D5096S-100. But what are the difference between these two kind of models? The D5096S is a Smart Relay with fixed diagnostic with the possibility of mirroring a fault in the field directly to a digital output card compatible with this functionality. This type of relay is SIL3 for both normally energized and normally de-energized application. And the mirroring function is performed through a change in impedance of the input relay side. But not all PLC DCS systems are able to correctly read this impedance variation. For this reason, the D5096S-100 variant was created. This kind of relay has the same diagnostic function as the D5096S, but as an universal mirroring system compatible with all PLC DCS systems, since inside the relay, it's placed in series with the input circuit, the fault transistor. In this way, when a fault in the field is detected, the input circuit is opened and an open circuit is shown to the digital output card of the PLC DCS. It's important to keep in mind that this relay is SIL3 for normally energized application, but is SIL2 for normally de-energized application. Let's see what are the diagnostic opportunities that these two relays offer towards the field device. When the load is activated, the relay contacts are closed and it's able to monitor continuously the voltage applied to the load and the current flowing through the load. Instead, when the load is deactivated, the relay contacts are open and it's able to monitor continuously the power supply voltage of the load and the load impedance. Now introduce another models of our smart relay with fully configurable diagnostic in all its parameters. The model is D5294S, and this smart relay, in addition to offering all the advantages of the smart relay seen above, adds other features such as a fully customizable diagnostic on the type of load to be used, the ability to read and write data from the module via Modbus RS485, and offer an internal diagnostic of the integrity of the coil that make up the matrix of electromechanical relays. And finally, give the possibility to diagnose a leakage between load and earth. Moreover, these relay modules support Modbus communication over an RS485 cable, and up to 127 modules can be arranged in a multi-drop network and monitored, configured by a single master unit. Each slave contains a table of parameters. Each of them is unequivocally identified through an address, and when requested, makes available its value for reading or writing. But what are the advantages of using Modbus communication? Well, with a single Modbus master interface, it's possible to connect and communicate with all the relay present on the same bus. Multi-drop connection is possible, and communication can cover a distance of up to 1,200 meters. And another advantage is the possibility of not using a dedicated digital input system to monitor alarms. This functionality allows us to have a significant saving in terms of cost. And again, real-time information on the type of alarm and on the health of the load and the line. It's also possible through Modbus a complete remote programming of the relay. Also in this case, analyze the diagnostic section of this smart relay, checking what is this functionality allows us to monitor. The smart relay is able to detect line and load fault, both in energized relay condition and de-energized relay condition. What we can monitor when the relay is in the on state. For example, a typical application could be the monitoring of a normally energized valve. Well, when the load is activated, the D5294S is able to monitor continuously the voltage applied to the load, the current flowing to the load, and also the internal coil's integrity. This specific model of smart relay has the possibility to performing an internal diagnostic of its coil, and in the event of the fault, report this fault to the system. But what can we monitor when the relay is in the off state, typically fire and gas application, where we need to know the health of the field load. When the load is deactivated, the D5294S is able to monitor continuously the power supply of the load, the load impedance, and in this case, the leakage from the load to the ground. The relay can monitor the leaks resistance between the earth and the load. Now let's examine specifically the typical configuration software of our smart relay. The D5294S can be also configured when the parameters to be monitored are really specific and the alarm triggering is not achievable with standard monitor relays. It's also possible to monitor the status of the loop in real time with the configurator. To a dedicated software and a small hardware interface, we can completely configure the module. For example, we can set up a window in which the value of voltage on the load, current flow in the load, or impedance of the load are included. In this way, when the measurement of the variable in the field come out of this window of configured value, an alarm is reported to the system. Through the configuration software, it's also possible to read in real time the value of voltage, current, and load impedance. Let's see specifically how the relay can communicate with the system. Smart relay can report the field status to the system in several ways. First of all, the two fault contacts can be acquired by a system dedicated digital input card of our PLC DCS. This is the typical way, which implies the use of this DCS with a dedicated digital input card, where the state of the contact, called a fault, is monitored by the system. The second method, for example, is if the system digital output card driving the smart relay support pulse testing, the fault in the field can even be mirrored directly to the digital output card without the need of an additional digital input card. And again, the fault on bus can also be acquired by a digital input card of our system. The fault on bus is normally used when a cumulative fault from many modules is required. Or again, complete diagnostic information can be retrieved through Modbus multi-drop RS485 protocol if a Modbus master is available on our safety system. Remember that through the Modbus protocol, the relay can be constantly monitored and also configured remotely. Let's see now in more detail what is the mirroring function of the smart relay. This function allows us to reflect information related to the field fault directly to the supervised digital output card of a PLC. This functionality works in both relay condition, off and off, on and off, and detect this system through an upward impedance variation of the relay input circuit allows the supervised digital output card to see a fault in the field. This system allows considerable saving in engineering cost, as it allows us not to use a dedicated digital input card for this purpose. Well, Andrea, now I leave you some time to explain the difference between safety and availability.
Okay, thank you, Massimo. We don't see any question from our attendees. Hope they're still there. They're still following us. Okay, let's wait for your question if you have it, of course. Yes, safety and availability. If frequently, I'm pretty sure you are encountering this question of what is safety, what is availability. In the SIL application, availability is not a must, so it's not required. So a SIL product looking just at the safety aspects of the product. So the availability is something more. It's something more that in Gemini we decided to introduce in a lot of, not all, but most of our products. So in the relay, for instance, we can say that these two relays we have just analyzed with the slides by Massimo. There are 4 relays inside. So looking at the circuitry inside, that is what happens. So you have 4 relays in the matrix where you have 2 relays in series with the load with the other 2 relays that go into the power supply. So that is the offline condition. The normal condition for normal energized load is when all relays closed, okay, and the load is powered simultaneously. So, and the safety condition will be when, of course, the coil is activated by your digital output, and simultaneously, of course, all the relay open and the circuit is also deactivated. And the 4 relays play a nice role, big role in this aspect for safety, of course, but also for availability. Let's look at the availability. Availability is when the one relay is not working, is not opening, or is not closing when is demanded by the system. And we can just give you information here. One relay is not affecting safety function. So hardware fault tolerance is equal to 1, and one relay is not really affecting, and the system is going in the safety mode, even if there is one single fault inside the relay. Maybe we have other slides later for this application. Massimo, is up to you again.
Okay, now we analyze some real application in relation to different type of load and the importance of the end-of-line resistance. Take, for example, devices as a sounder. Typically, those devices, especially in the off condition of relay, show to the later a very high impedance, often outside the diagnostic range of the smart relay. Or in the on condition of the relay, they show for a very short distance a full condition due to the capacity front end of the device. This problem often occur with these types of field device, and to overcome them, it's necessary to insert the resistor in parallel to the device cell, which allows to bring the impedance value of the field device within the diagnostic value of the relay. In other cases, however, this field device, again due to their strongly inductive or capacitive front ends, generate strong reverse current peaks, which risk irreparably damaging the relay contacts. To overcome this problem, it's necessary to insert protection devices, such as PTC or power resistor, able to dampen these dangerous peaks. And again, we see in the slide these protection devices are placed in series with the field device, while the end-of-line resistor must necessarily be placed in parallel and as close as possible to the terminals of the field device. The value of these resistances of PTC must necessarily be evaluated from application to application based on the value of the load supply voltage. Some words about the connection of the relay can be unipolar or bipolar. A bipolar connection allows a complete isolation of the load, and this is recommended especially in application where the load must be powered with high voltage. From an electrical point of view, this type of connection grants a great safety thanks to the complete isolation of the load. In unipolar connection, instead, isolate the load only one of the power supply lines and bring a negative to 30 in case of need. Furthermore, this type of connection save a lot of cable cost. Only as regarded the D5294S model, it's possible to configure the relay to have a diagnostic on the field device, even in condition of the load connected in unipolar mode. Of course, we must consider the bipolar type connection as ideal and standard for an optimal functioning of the relay diagnostic. However, the D5294S guarantees, even if in a reduced way, a diagnostic of the field device connected in unipolar mode. It must be configured via software and connected as shown in the slide. In the on state, it will be able to monitor the current circulating in the load in this way, and it will provide us with the information on the health of the field device and the on-the-loop connected to it. With the relay in the off state, we will be able to monitor the power supply voltage of the load. Well, Andrea, I think we have another poll.
Yes. Okay, this was the, let's say, the slides regarding the line monitoring for the unipolar for the 5224, explained by Massimo. Okay, let's see, you are still there because we don't see any sign from you. Maybe we can have, and we have another slides and the poll. If you want to answer regarding the safety features, what do you consider is very important in the safety relays the pass test compatibility, meaning that the pass test from the PLC is compatible with the safety relay. What is in case of fault, the alarm contact is a good features. If it's maybe the Modbus interface, that great features. Or if also the configurable threshold. There we have seen some loads like special with high inductance, like beacon sounders can be challenging. And also if the mirroring functionality on your card, meaning that you don't use a contact for acquiring the fault, but just from your digital out you acquire the fault. If you want to answer to this question, please go ahead. Wait another few seconds. At least wait until 50% of people answer. Okay. Okay. We see a lot of different answers on this point. If you wanna close, we wanna close in a few seconds. This poll, please go ahead. Okay, no more questions. We can just share the results. We see that the fault mirroring is very important from you, but also other features like, of course, configurable threshold and Modbus interface. Configurable threshold is only available on one mode, two modes from us, not all, of course. It's the most complete with the Modbus and so on, as these features. If you need, of course, any question, you can just write us or call us, whatever is important. Okay, let's go ahead. With the next part, we see that now the line monitoring for isolators, which is also a part with more and more requested from the users. So when you introduce an isolators in the system, you need, of course, sometimes you need this kind of features. So intrinsically safe isolators, you can see modular solutions that you can use for single or multiple IOs for any kind. It can be AI, ODI, IDO, temperature, pulse, vibration, load cell. Certification SIL2, SIL3, depending on the unit. And the safe area mount is for safe area zone 2, but the connection, of course, for IS part is with the zone direct with zone 0 or zone 1 or zone 2. And for some unit, also the Modbus protocol is available that give you much more, let's say, features like for the monitoring especially. Let's see for analog input what is let's say the line monitoring functionality. Let's say that of course we're talking basically in the 4 to 20 milliampere range. Okay. When the loop is the current is lower than 4 milliamps, meaning there is an open circuit. When it's over, basically there is a short. Over the 20, there is a short circuit. Let's say that in a more compliant transmitter, say that the range is between 3.8 and 21 milliamps. The line monitor is intrinsic, say, in the unit because our unit transfer transparently all the information. So if there is a current between lower than 3.8, it will be transmitted, and also over 21 will be retransmitted, and the system itself will see that there is a problem on the loop, which is, let's say, controlled and signaled immediately by the system. Different is for analog outputs. Okay, so for analog output, when the load, there is a short output, the detection of the load resistance is lower than 50 or 100 ohm. This is selectable on our device. And there is, of course, a detection for the open wire when the load resistance is higher than 4.9 ohm at 4 milliamps. There is a special values. How is signaled this information is reflected to the system by high impedance to the control system. So basically your digital, analog output card can detect immediately this high impedance, okay? But of course, there is also in some cases where your system is not able to detect this high impedance. There is a contact output, there is a transistor output that can be collected over your digital input card. In this case, you need an additional digital input card. But however, basically, the high impedance is a good sign, and most of the system can acquire this information without using the additional contact. We have developed different units for digital input with line monitoring, with a lot of numbers. SDX don't care about that. Care about if you want to have a SIL3 or SIL2 modules, okay. And for SIL2 and the D5039, for the SIL3 D5038. These are equipped with some resistance, okay, that give you information about the status for they can detect different values in case of short and open circuit. That is very important for your system. You want to have also the solution for digital outputs, and they will close all the things, so AI, AO, DI, and VO. In this case, also the digital outputs, when there is open output, the load resistance, they see that the load resistance is higher than 10 kiloohms, or the short when there is a load resistance lower than 50 ohms. As for analog output, also digital output, the high impedance is reflected to the system, or there is also a fault contact available. Massimo, I think is your part now for power supply.
Okay, now let's talk about the power supply system of our SIS. GMI has various solutions regarding SIL certified power supply system that can be installed in hazardous areas too. Before going into the specific operation of safety power supply system, let's see a quick representation of the products offered by GMI in this field. The power supply safety system can be composed in arrays of up to 6 elements, each of which with 50 ampere, 90-inch rack with onboard diagnostic module, or alternatively, we can have a 9-inch rack with 2 50 ampere power supply on board plus a diagnostic module, or a 7-inch rack without a diagnostic module. All our racks have the redundancy of the power supply modules to obtain different working configuration. Finally, it's possible to obtain single module of 50 amperes or 20 ampere, which can be placed in parallel to have up to 10 modules connected in current sharing between them. Now, let's take a look at power supply. But what are the possible risks and conditions that we consider dangerous in relation to the use of power supply? The concept of safety is very important also with regard to power supply system, because the failure of power supply can cause serious accident to lead to serious loss in terms of human lives, serious environment damages, and serious cost losses for companies. For this reason, it's necessary to have safe devices that guarantee high performance. But what are the dangerous conditions for a power supply system? Well, mainly there are two dangerous fault conditions. The first one is an undefined load voltage in a range between 2 and 20 volts must be considered as dangerous failure of our power supply. This is because an incorrectly powered load works or can work out of specification, and this leads to a reduction in a load performance that can cause a premature instrument failure. Often we try to avoid this issue using redundancy, but we wrongly think that two power supplies in parallel are sufficient to make us immune from possible faults in the power supply system. redundancy cannot solve on its own and cannot guarantee us immunity from power supply failure, because a standard power supply, it does not take into account the common mode fault that can afflict standard power supplies. This common mode fault can cause spurious system fault with the related production downtime, which would significantly affect cost. The redundancy of power supply minimizes this risk because common fault failure are considered in SIL calculation necessary to get certification for a safety-related device. The second dangerous failure condition of a power supply is when the output of voltage reaches a value higher than 30 volt. In this condition, the load is subjected to an extra voltage, which can damage it. Or in case of output voltage higher than 50 volt, the field instrumentation can suffer a definitive disruption. We can take, for example, an engine cooling system, which works thanks to a standard power supply. Suppose that this standard power supply fails and goes into an overvoltage condition, damaging the cooling system. This will lead to an overheating of the engine, which will lead to serious consequences for the whole system connected to it. A safe power supply system grants high performance and high safety. So why it's correct to use a safety power supply system? Below are the main reasons that leads us to advise against the use of a simple standard power supply. A standard power supply is not designed based on the directive of the ESC 61508. It does not have made a calculation defined for the safety function to be obtained. It does not allow to have a redundant protection from overvoltage issue, while in a safety power supply system, redundant protection are a fundamental requirement. And again, standard power supplies can be used in a redundant configuration, but they do not guarantee that our application is totally safe for the reason related to common fault, which I've seen previously. And also standard power supply often require external or ring diodes for redundancy. This means to add external wiring that, especially for high load current, create a high voltage drop, which has a strong impact on the supply voltage. It's true that it's possible to adjust the output voltage to compensate for the voltage drop, but this operation increases consumption considerably. In addition, a standard power supply has a higher number of spurious faults than a safety power supply. We know well how a spurious fault can also lead to dangerous failure for the application. And also standard power supply use internal components with the limited operating range to keep costs down. This affects the lifetime of the device. For this reason, internally to the safety power supply are used components with a higher operating range that allow the system to work at a lower stress level. This leads to less failure and consequently a considerable longer lifetime than standard power supply system. Well, at this point, why it's important to use a safety power supply system? First of all, we know that the standard voltage for a normally energized load is in the 20-30 volt DC range. As we have seen previously, conditions that lead to power supply output voltages between 2 and 20 volt and then higher than 40 volt are considered dangerous failures, which negatively affect the application. Well, a safety power supply significantly reduce undetected dangerous fault thanks to a built-in diagnostic system. In fact, if an anomalous output condition is detected by the safety power supply diagnostic, it brings the output to 0 volt, which represents the safe fault condition. Plus, a fault transistor are like the PLC system, which connect as per specification. Another huge advantage that safety power supplies give is the presence of the all-round diodes inside the device. This grants a huge cost advantages, as it's not necessary to externally wire the diodes for each unit that is a part of the redundant power supply system. GMI power supplies do not request external ring diodes for output parallel configuration because each GMI power supply has got internal. An active ideal diode realized by MOSFET and related control circuit components, replacing old method with Schottky or ring diodes. This increases efficiency, reliability, and availability, and reduce space about not use Schottky diode it sinks. MOSFET active ideal diodes with a related control circuit provides also very smooth voltage switchovers without oscillation, with fast turn-off, minimize reverse current transients. Below, in the slide, we see advantages that the ideal diode system inside a safety power supply system brings compared to a standard power supply. We see, for example, a voltage drop at 50 amperes, 0.8 volt for Schottky for all the Schottky diode, only 0.06 volt for our system with the active ideal diodes. Redundant system and load sharing. This purely hardware control is complex and based on output current measuring that each power supply module executes. Typically, load current sharing capability is a necessary feature for medium and high load current. All GMI power supplies can be parallel on their output and their internal load current sharing circuit operate to distribute current load equally to each power supply module to increase reliability and reduce internal power supply dissipation of each module. Another advantage of load current sharing functionality is request of little system output voltage modification when two or more power supply modules are normally operating. To conclude our presentation of the power supplies, we have another important feature is the short circuit proof system. This system avoids that in the event of a short circuit of one of the load connected to the power supply system, there is no system shutdown. In fact, when the protection circuit detects a short circuit on the line, it sends a current peak that can reach up to 800 ampere for a maximum of 0.5 milliseconds, able to interrupt the protection fuse or the circuit breaker associated with it to interrupt the power supply to the short circuited load and safeguard the rest of the system. Well, Andrea, we finished the part related to the safety.
Thank you. Okay, thank you, Massimo. We have practically finished. We have also some questions you made during your registration. We want to share with you. Of course, in the website, you can find everything. So let me close this presentation and switch to the other. In the meantime, if you have any special things, let us know. Okay, we can start with the new ones. Q&A. Okay. Yes, okay, fine. We have this. Okay, so we have some questions we received during, I think you can recognize it. So extended integration DCS is safe in a common mode. We have tried to answer this point. Integration control safety systems is possible for the design, maintenance, and management of the plant. But the integrated but separate offer complete integration, complete separations of the two extremes. So it's very important to, as you can understand, separate the architecture, and maybe, and say Massimo helped me in this answer to this point. So I think it's very important that you keep the, let's say, the cell level of the loop, which is connected to the safety systems, let's say, separated, physically separated, maybe isolated from the loop, which is in the DCS part. Massimo, what you can say about this point for integrated? The answer?
We know that the integrated SIS DCS does not imply that it's one common system. It's just integrated for easy of use and convenience. Thus, the configuration software may have different types of logic blocks. Some meant exclusively for use in safety function, whereas other can be used in normal BPCS function. The logic solver control needs to communicate with other logic solver, then it has to be over a safety bus, a communication bus that is robust enough to carry safety critical data reliability. And thus the integrated system is not really totally integrated, but is much more close than the early to the totally standalone system.
Okay, hope we answered. How do you define SIL3 design requirements?
Well, I think you mean the SIL3 design requirements of intrinsically safe isolator or smart relay. Well, there are plenty to minimize both random failure and systematic failure. The ESC 61508 standards provide guidelines for calculating random failures and the requirement for to be met to limit systematic failures. Furthermore, the standard provides the requirements that company which design a functional safety product must have at all levels, for example, functional safety management requirements. Going into all the requirements in detail takes time, which cannot have in a webinar session. And above all, the requirements also depend on the complexity of the product.
Okay. We have a question regarding the SIL manual. We can answer later because we have here a question dedicated. So about the SIL3 installation of hazardous SAR, is it true that EX certified products aren't necessary? This is very, say, frequent questions. We can answer that is completely false. If you use an hazardous SAR allocations and you use a SIL3 product, it's not, say, replacing the certification for hazardous SAR. The unit which is SIL certified must be also suitable for the hazardous SAR installation, and must be suitable for installation in this area where you want to connect with the field. So it's really are two words completely different, and hazardous SAR allocation is I would say that is a must, and you have to follow the hazardous SAR allocation norms. SIL is something more is dedicated for say safety critical application where there is no explosion areas application. So of course hazardous allocation is necessary. So another point is intrinsic safety calculation is required or not to well select the IS device for SIL3. So calculation, also in this case, the answer is, of course, is very important. So intrinsic safety calculation is mandatory. It cannot be replaced while you are selecting SIL3 devices. So another point is how to identify the SIL application, identification of the SIL label, and how to select the instrument automation system for the SIL application. This is not our part, I would say, because of course must be carried out by system engineer, safety engineer, and we also say we are only offering the units that are suitable for the application. However, we developed this, we print out this book, the SIL manual, that is available for customers. So just to answer to the people that ask that, this can be required freely to our, you can write to us, you can write also in the form, which is on the website. You will get it for free. Just I think the cost, to add the cost for the expedition, or maybe you can refer to our local office if you are in the area and so on. But basically, the book is free for the customers. Another point is a digital transformation related to SIL application and modernization. Massimo, you want to say something about this point?
This is a very difficult to say, because certainly the increase in use of microprocessor involved in the functional safety function require an extension of the functional safety, and analysis related to the software installed in them, especially if required safety level is SIL or higher. This is possible following Route 1S in the path of excellence, but certainly is a way that have a higher cost and complex. However, there is an alternative, which is to follow the Route 2S, that is for proven in use device, generally applicable only to reach SIL2 level.
Okay, other point is mandatory IC and a requirement for instrumentation intended for hazardous area shall be SIL capable. So those are mandatory requirements that the instrumentation intended for the hazardous area shall comply with the standard for hazardous area. The same history of before. So SIL capable is something more for the device you are using, but first, if you're using a hazardous area device, it must be compliant with the area where you are using the devices. So we have a last question. Ethics is not related to us, but we want to talk about that, because ethics field devices 0-20 milliamp signal with diagnosis and heart protocol at the same time. Basically, all devices, we don't produce a sensor, we just produce interfaces, and our modules are compliant in the range between, say, 3.8 and or even less, and 20-30 milliamperes. So they are transmitting completely transparently the signal over 4-20. But there is also, of course, this HART protocol, and this HART protocol is, of course, it must be transmitted over the field devices, and is transmitted through our modules, through our analog modules into the system. This give you all details about say, the healthy of the device, the value. So beside the 4-20 milliampere signal, you know much more parameters about the device itself. So it's very important to use when it's possible. So the HART, maybe this hard information is managed by the system where there is hard multiplexer inside, but maybe not. In this case, we can be of help, of course, because we have a multiplexer for hard communication that can be used. The multiplexer basically is separated, is not interfering in the safety loop, is separated, and there is a PC-based system where you have the hard management software that acquire all data about the system. I think we answered to a question more or less. Maybe you have others, maybe not. We want to just say thank you, and maybe we want to, of course, ask you how did we do, if you want to answer to this question. Massimo and I will be, say, of course, available for further questions if you need other things you want to, beside that, beside Gemini, beside SIL and Azar. We have also technical expert that can give you much more details than us. And thank you again for participating in this webinar. So most of you lasted the end. And we thank you again. We remind you that there are other webinars available. You can look at our LinkedIn page or maybe in our web page. All webinars are for free, and you can also see this webinar because it has been recorded, and will be recorded also the other recordings. So we have a YouTube page where all webinars are there. You can look and you can share with all your people. Okay, thank you again. Very good. Thank you for the answer. Massimo, thank you. And
our attendees for the participation.
Okay, we see you next time.